We weren't talking about anything. Okay, here we go. P7. Last lesson. All right, we're going to do some solving inequalities, which is kind of funny because I just did solving inequalities in my Algebra 2 class, but those were linear inequalities, and that's, that's too basic for us. We're going to solve some harder inequalities. We're going to solve some absolute value inequalities today, some quadratic inequalities, and we're going to do them two ways. So you'll want to get your calculator out for the day. We're going to use it in a little bit. We're going to solve inequalities graphically and algebraically, both, okay? Whoa, 4 parts today. Okay, it's a long one. Here we go. It's going to take a while. The first thing I need to talk to you about is something called interval notation. You haven't used this yet, probably, or maybe you have. If you took Algebra 2 or Honors Algebra 2 here last year, we didn't do interval notation. So I'll show you what it is. It is used in this class, and it's also used in calculus, so you need to kind of get used to it a little bit. I like it better than inequality notation. Some people don't. I'll show you why they don't. It makes sense, but I still like it. Okay, here's what interval notation is. Let's start with something that you know. We're going to write the inequality in inequality notation. We're going to go ahead and translate that to interval notation. And we're going to draw the graph of it. This is not an XY graph. Bless you. This is just a number line type of graph, okay? All right. So here's something that you're used to. You're used to A is less than or equal to X is less than or equal to B, okay? And A and B are real numbers. And we could say something like 2 is less than or equal to X is less than or equal to 5. And that would be numbers between 2 and 5, including 2 and including 5. Okay? Interval notation, this is how we write it. We write a bracket with the letter A, comma, B. End with a bracket, okay? This is interval notation from A to B, including A and B. Now, let's change this. We'll graph it in just a second. Let's change this to strictly A is less than X is less than B. Okay, what is that going to look like? That's going to be a parenthesis. So a parenthesis does not include the numbers on the outside. And this is A to B. And this is why people don't like interval notation. Because if I said something like, okay, the interval from 2 to 7, what does that look like to you? A point. That's XY coordinates, right? But it's not. That's an interval notation. It's from 2 to 7. Not including 2, not including 7. When you graph it, in Algebra 2, you used closed circles and open circles. Here, they just put the brackets right on the graph, which is fine. If you want to do closed circles and open circles, I have no problem with that. That's the way it usually is done. But this book seems to do something like that. And then when they do this one, they'll just put the parenthesis right there. Okay? So the first interval is called a closed interval because it includes the boundary points. The second interval is an open interval. You could have a half open, half closed. So let's see what that looks like. If you had A is less than X is less than or equal to B, something like that, that's a half open. That interval notation would be from A to B. A has a parenthesis around it because it's not included, but B is a bracket, it's included. Okay? And if you were going to graph this, it would be a parenthesis at A, bracket at B, and all the stuff in between. Oops, I forgot to graph the stuff in between. Okay, what about something like this? X is greater than A. X is greater than 5. X is greater than -2. Something like that, okay? Here's how we list this. If we're talking about numbers that are greater than A, we're talking about numbers that start at A and go off to where? Starts with an I. Infinity. That's what we're going to write. A to infinity. You never include infinity. Infinity cannot be bounded, so it goes on forever and ever. It's always a parenthesis on infinity. If this was x is greater than or equal to a, one little thing changes. What is it? Bracket. That's it. That's the only thing that changed. Okay? So when you graph these, you would do like here's a, and I would graph that and going off to infinity. This one would be, and just like I said, you can use the open and closed circles if you'd rather. Okay, the one that's tough for people is the one that goes the other way. If I say something like x is less than a, okay? X is less than a. These interval notation that we're writing are always smaller to bigger. I would never say, hey, the interval is 5 to 2. No one says that, okay? It's 2 to 5, smaller to bigger. So this one would have to start with negative infinity to a. Negative infinity to a. And so when I draw that, here's a, and I would be going to the left. So when I read that, I'm really starting over here at negative infinity and going to a. So you read intervals, you read them left to right. You read graphs left to right. Okay? Bracket would be if you had x is less than or equal to a. So you would have negative infinity. Don't include infinity or negative infinity with a bracket. Has anyone ever used interval notation before? Anybody? Yeah, a couple of you guys? Good. It's just something you have to get used to. It's not that bad. You might like it. I don't know. You might hate it. We'll see. So here's a. It's all the stuff to the left. Okay? This interval up here, this x is less than a or in negative infinity to a, that's an open interval. This one's actually closed, even though it looks half open, half closed. It's a closed interval. Just kind of interesting. All right, here we go. Let's go ahead and practice a couple of these, okay? So number 1. We are going to convert and graph. Convert and graph. And this is just like the first few in your homework tonight. Convert the interval notation and graph it. Do they do it the other way? Let me see. Okay, so here we go. Convert this. Interval notation, negative 6, 3. We're going to convert that into inequality notation, and we're also going to graph it. So this says that we have an interval from negative 6 to 3, including negative 6, but not 3. So if I'm going to rewrite this, negative 6 is over here, 3 is over there, and the inequalities, or alligators, whatever you want to call them, they always go the same direction. So this is going to be x in the middle, and negative 6 is less than or equal to x is less than 3. And then we go to graph it. People like to put 0 in the middle, put negative 6 down here, positive 3 right there. I'm going to include negative 6, parenthesis at 3, all the stuff in between. Okay? Do you kind of understand it so far a little bit? Maybe? Let's do another one. Let's do negative infinity to 10. Negative infinity to 10. So let's convert this into its inequality form using inequalities instead of interval notation. So how would I write this? X is what? Perfect? 10. X is less than 10. Good. And let's say there's 0, 5, 10. X is less than 10. If you prefer the open circle, draw an open circle. I think the back of the book might have brackets and parentheses, but that's okay. You get it. All right, now let's go the other way, and this will be the last one of these, and we'll move on to actually solving some inequalities. Negative 2 is less than x is less than or equal to 7. Okay, that's an inequality written in inequality notation, the way you're kind of used to it, compound inequality. Go ahead and translate that or rewrite that into interval notation, if you can. So we'd put a bracket at a parenthesis at -2 and a bracket at 7. Anybody get that? Yeah, good, good, good. Okay, and I'm not going to graph it. I've been graphing too much today. All right, part B. Part B. So that was just getting us ready to answer the questions that are coming up and putting them into interval notation. So we're going to start with two problems that you did in Algebra 2, but these were done back in like Chapter 1, so you might not remember how to do these. We're going to do some absolute value inequalities. Absolute value inequalities. And there's really two types. Okay? The absolute value inequalities, if you had an absolute value and you're saying that that's greater than A, or greater than or equal to, it doesn't really matter. And if you have an absolute value and you're saying it's less than A. Okay. Absolute value is a distance, right? If I take the absolute value of -5, I get 5. Well, why is that? Well, because absolute value is a distance from 0. So -5 is 5 away, and +5 is 5 away. They both get 5. What this is saying is my absolute value has to be bigger than a number A. So if I was going to look at this on a number line, my numbers in here would be bigger than A. Okay, the distance is going to be bigger than A away. So let's say here's A. My answers would be over there. But what else is bigger than A? Absolute value. Farther away from A, I would go over here and go in that direction. So think about it. If this was absolute value of x is greater than 7, if I put in -8, that's going to work, right? So either my answers are going to be farther than A away this way, or less than -A that way. It's all the way up. Greater than, people used to think greater, and this is actually an or statement. I'm greater than A, I'm less than -A. This one is going to keep us confined. This is saying that my distance is going to be less than A away. Well, less than A away would be if I went to -A or +A, and it would be all the stuff in the middle. This is an and statement. Less than, that's what some people said in my Algebra 2 last year. A little stretch, less than. So let's do some. Here we go. And we're going to solve these algebraically. We're not going to use our calculator just yet. Number 2. The absolute value of x minus 4 is less than 8. Less than 8. Okay? So I have to think about x minus 4 as its own thing. X minus 4 is going to be smaller than 8. So if I told my kids, you guys can only go 8 feet away from me, then they can walk 8, like let's say we're on a line. They can walk 8 feet that way, they can walk 8 feet that way. They can't go past that. Okay? So you have to confine it between two things. Less than 8 means I got to keep this between, what is that symbol right there? I got to keep this between -8 and +8. Do you remember these last year? These were hard. This was like the first hard thing we got to in Algebra 2. Okay? So less than, it's an and problem. And then you just add 4 to both sides, or all the sides really. And you get -4 is less than x is less than 12. Okay? And they'll want this in interval notation as your answer. So there's one extra step for you where you get to say -4 to 12. Always smallest number to biggest number. It's not a point, it's an interval. Okay? All right, let's do the other way. And then we're going to graph this, and I'm going to show you what it looks like graphically. Excuse me. Let's do the absolute value of 3x minus 2 is greater than or equal to 5. So here I am this morning arguing with my children, and I say, oh, you guys, I cannot stand you right now. You have to get at least 5 feet away from me. So here we are standing. They can go 5 this way and go past that, or they can get 5 feet away from me that way and go past that way. Okay? So basically it looks like this. 3x minus 2, this whole stuff inside of here, can be less than or equal to -5. Or, so they can go that way, but is that? No, that's negative for you guys. That way. Or 3x minus 2 will be greater than or equal to 5. They're going to go in the positive direction, farther than 5 away. Okay. A lot of people think that this, you just flip the sign because it's negative. You flip the sign when you're solving and you divide by a negative. Anyways, all right, add 2. 3x is less than or equal to negative 3. So x is less than or equal to negative 1. Or add 2. 3x is greater than or equal to 7. Divide by 3. X is greater than or equal to 7/3. Okay, now here's how you write this in interval notation. You're going to write 2 different intervals. These are not connected. See the or in the middle? This or that, they're not overlapping. X is less than or equal to negative 1 would be all the numbers that are from negative infinity to negative 1. Okay? X is less than or equal to negative 1, negative infinity all the way to negative 1, including negative 1 because it's less than or equal to. Or, I'm going to show you, you're not going to write the word or between, okay, so leave it blank for right now. X is greater than or equal to 7/3. So 7/3 to infinity. And here's the symbol that they put in the middle of this thing. Does anyone know what that symbol is? It's a U, right? Looks like a U. That stands for union. Union. Okay. Both answers are together. You get very symbol-y. Symbol-y, I don't think that's a word, but we're going to go with it in this book. Very symbol-y. Okay, let's go ahead and go back to the problem number 2. And let's graph this one on our calculator. Okay? Some of you can graph this by hand, right? Do you know how to graph that by hand? This is just an graph absolute value of x minus 4. It's just an absolute value shifted 4 to the, no, right. I'm not going to make fun of you if you're wrong. I will celebrate if you're right, though. Okay, so go to your calculator, and let's graph this. I'm going to pause. It's been shifted 1, 2, 3, 4, and it's an absolute value graph, just basic. Looks like this, looks like that. And then we have the equation y equals 8, which is up here, and it goes off of our screen on our calculator. All right, this number right here, intersection, is negative 4. And I know that because my interval is negative 4 to 12. This one way over here that's off of our screen is 12. Okay? If you want to find those numbers, you can go ahead and calculate the intersection. Remember we've done that already this year? Second, trace, number 5, enter, enter, enter. It'll find one of them, go over to the other one. You might have to change your window, though, since it goes all the way to 12. Okay, now let's think about inequalities. They're asking us, where is this absolute value less than 8? This absolute value less than 8. Okay, so here's 8. They're wondering, where is it below this line? It's below the line here and here. And that's it. This part, right here. And what is that interval? Between negative 4 and 12. Okay? So we did it algebraically, which you're probably comfortable with because you did that last year. Well, this is what it looks like graphically. Above the line, above 8 is up here and here, which is the outside parts of the interval. Okay? So we wanted the inside part. This part right here, which is from negative 4 to 12. Okay? All right, let's move on. Any questions, comments, suggestions? No? All right, good. Letter C. All right, now we're going to solve quadratic inequalities. And you haven't solved quadratic inequalities yet, I don't think. Some of you might have. Most of you have not. We're going to do this algebraically and graphically. And a lot of these you can graph without your calculator because you know what a parabola looks like. So here we go, number 4. Solve. X squared, and write in interval notation. X squared minus x minus 12 is greater than 0. All right, x squared minus x minus 12 is greater than 0. What are you dying to do to this right now? Yes, me too. Dying to factor this thing. All right, let's factor it. All right, what times what's negative 12 adds up to negative 3 would be a negative 4 and a positive 3. All right, so some special points that come about from this would be x equals 4 and x equals negative 3. Okay. Those are not our answers. Okay, those are just the zeros of the graph. So this is what I want you to do. I want you to draw a little picture of this graph. And go to 4, and go to negative 3, and go ahead and plot those points. And this is just a graph of a parabola that's facing what, up or down? Up, because A is positive, the leading coefficient is positive, so this is our parabola. And we're trying to see where our parabola is greater than 0. The line y equals 0 is the x-axis. Okay? So where is this parabola greater than 0? Where is it above the line? Well, it's greater than 0 right here, not including this guy, because that's where it equals 0. And then it's greater than 0 here and up. Not in the middle. It drops below the line y equals 0. So just those. Well, that's 2 intervals. And I'm going to write them in interval notation. So this interval over here is negative infinity to negative 3. And this interval over here is 4 to infinity. And I'm going to put a little u in the middle to combine them together, but they're not like combined together. I'm saying that's my entire answer. Okay? So that's kind of a mix of algebraically and graphically all in one. Algebraically and graphically. The other way to do this, which I've taught in the past, once you get those numbers, 4 and negative 3, you can graph them on a number line. You might like this better. Here's negative 3. Here's 4. And what you do is you test your intervals. You pick a number over here. You pick x equals negative 4, for example. And you plug it into your equation here. And you get a negative, what is that? A negative times a negative gives you a positive. Then you pick a number between negative 3 and 4. Maybe x equals 0 is a really good one. And you plug it in, you get a negative in the middle of this section. So you have these numbers, and you're testing this interval, and that one. And then you pick maybe x equals 5, and you get a positive. So you want to say, where is this greater than 0? It's greater than 0 here and here, but it's negative there. That's another way to do it. That's a little more complicated, huh? I like the graph. Let's try another one. Let's do this one on our calculator now. Number 5. Where is 2x squared plus 3x greater than or equal to 20? Where's 2x squared plus 3x, oh, did I say greater than? I meant less than. Sorry, less than or equal to 20. My bad. All right, what do you think we should start by doing?
Bring the 20 over.
That's what I would do too. All right, so we're going to go 2x squared plus 3x minus 20 is less than or equal to 0. And you can do this one algebraically, but I'm also going to say you can do it graphically. So let's go ahead and graph this. Let's say I don't want to factor this. It has that 2 out front. I don't like that. And I'm going to go ahead and graph this on my calculator. So get your calculator out. We're going to go y equals, we're going to graph 2x squared. Can you see that? No. All right, I'm going to pause the video for All right, so we graphed this on our calculator, and it looked something like this. We couldn't see the bottom, which was no big deal. And we got that the intersection was of our line y equals 0 and our parabola. We got x equals negative 4 and x equals 2.5. And we would have gotten those numbers that had we factored. We would have gotten them too. Okay? All right. So was it 2.5? Yeah? Okay. So we have to now look, where is this parabola less than or equal to 0? Do you see where it's less than or equal to 0? This parabola is less than or equal to 0 in here, and including those dots that intersected at 0. And how would I write that in interval notation? I need a bracket, right? -4 to 2.5. That would be my answer. Okay? So this question is, where is this 2x squared plus 3x, where is this less than or equal to 20? Numbers between -4 and 2.5, and including them. All right, I need to show you a couple more that are some special cases, okay? So let's look at number 6. X squared plus 4x plus 1, where is that greater than or equal to 0? X squared, you know what, that should be a minus 4x, sorry. Get your eraser out. X squared minus 4x plus 1 is greater than or equal to 0. Let's graph this, okay? You can't factor this. Nothing times something is 1, adds up to -4. So let's go ahead and plug this into our calculator, and we're going to graph x squared minus 4x plus 1. All right, what do you notice? Oh, that's not a special one. Those are just ugly numbers. I thought I was expecting something else. Where's the, oh, it's coming up. Sorry. Okay, so you graph it, and you still get a parabola, and you get y equals 0, and you calculate the intersect. You get 0.27, and calculate the intersect again, and you get 3.7, okay? So the zeros are x is about what did I say, 0.27? Yeah? And 3.73. Okay? Those are our zeros. Pretty ugly numbers. That's okay. You would have gotten those had you used the quadratic formula, but graphing's nice. You know, your calculator will do it for you. It's really nice. All right, so that's this point right here was 0.27, and this is 3.73. Now, where is this graph greater than or equal to 0? Well, that would be this section of the graph with that number, and it would be this section of the graph with that number. Where is it greater than 0? Above the line y equals 0. Okay, when your graph is kind of split like that, you have this part and that part, remember you have to make 2 intervals. So let's do it. We have the interval -infinity to 0.27, including 0.27, because it's greater than or equal to, union 3.73 to infinity. All right, so let me throw in the one that I was thinking of. Let me make sure that it works real quick first. Because you could get some interesting answers. The ones we've gotten so far have all worked out okay, but sometimes something happens. I'll show you. I just want to make sure that this one works. Yep, okay. Number 7. Last one of these. I know I've been talking for 28 minutes right now. It's a long time. X squared plus 2x plus 2, and I want to find out where that is less than 0. All right, here's my special case. There's 2 special cases. I graphed this on my calculator just now. You don't need to. Let me show you what it looks like. We don't have to be very accurate because you'll see right away what's going to happen. This one goes through y-intercept of 2, and it looks like that. All right. I was trying to do this one earlier, but so where's this graph less than 0? It's not. Okay, so my answer to this would be no solution. You can draw a circle with a line through it. You can actually write the word no solution. If it was switched around and this graph was, where's this graph greater than 0 or even greater than or equal to 0, you would say everywhere, right? Your answer would be all real numbers. You can write it like that, all reals, or you can actually write the symbol for all real numbers, which looks like a weird R. That's the symbol for all real numbers. Okay, so that's our special case. Sometimes it won't even touch the x-axis, and it's either above it or below it, depending. Okay. All right, one more part, and there's only one example. Letter D. Have you had enough? Too bad. All right, who's in physics? Anybody? Physics? Yeah. Anybody want to be a physics major when they grow up? When they get to college? Maybe? Physics? No? Yes? It's just mathematics, like, applied. It's hard. Lots of word problems in physics. All right, we're going to talk about projectile motion. I always think of projectile vomit. You know, like in babies, they just go and they just vomit all over you. Projectile vomit. It's not good. All right, you'll see when you have children. Later, not now. Okay. All right. Projectile. Okay. It's a weird word. Projectile motion. Now, we're not going to talk about vomit, even though we already did. We're going to talk about something that's launched, like physics. You know, they launch rockets. It's very exciting. Anybody ever do cadets and you launched a rocket before? No? No cadets out there? Oh, my son did, and he loved it. It was so much fun. All right, well, here's the formula for an object that is launched vertically from a point above the ground, launched into the air, and what does it make when it comes back down? Oh, a parabola. Yes. Okay, so here's the formula for that. S is equal to, there's actually two formulas that you use. One has feet per second, and the other one's meters. And we're going to use the feet one right now, okay? So we're going to do negative 16t squared plus v sub 0 t, yep, I got some frowns on that, plus s sub 0. All right, let me tell you what all this stuff is. V sub 0 is what's called the initial velocity. The initial velocity. That's going to be given to you. You're not going to have to find that. Okay? Has initial velocity of blah, blah, blah. All right, S sub 0 is going to be the feet above ground. So if you're up on top of a second story and you're launching a rocket, well, that's going to make a big difference of where your rocket's going to go as opposed to ground level. Feet above ground. S is going to be feet, okay? S is a variable. As the object goes, it changes its feet from the ground, okay? And T is going to be the time in seconds. Seconds after the launch, we just write seconds. All right, so here we go. It says a projectile is launched straight up from ground level with an initial velocity of 288 feet per second. This is the last problem. I know it's been a lot for today. Number 8. So here we go. We're on the ground. We're going to launch a rocket or whatever we're launching, okay? And it says that we're launching it from ground level. Okay, that's important. And that our initial velocity is, so I'm going to say v sub 0 is 288 feet per second. Okay? And what we're going to do is we're going to answer 2 questions. First question. When will the projectile's height above ground be 1,152 feet? So, how much time? So when will the height of this projectile be 1,152 feet? And then we'll get to part B in just a minute. All right, so here we go. So what we're going to do, we first need to get an equation for this. All right, we need to see the path of it in an equation form. And we get that S is equal to negative 16t squared. We're going to put the initial velocity in, which is 288 times t. We're on ground level, so what is S sub 0? 0, perfect. Okay, so there's our equation for this problem. It's a negative parabola. It should be a negative parabola because it's going up and coming back down. All right, so when will the height be 1152? So let's take negative 16t squared plus 288t, and let's set it equal to 1152. Now you have 2 options. One is we can get everything over on one side, which actually we're going to do for both options. So let's just start by doing that. And I hate it when my first term is negative. I don't like that. I don't like when my t squared, the coefficient's negative. So I'm going to bring everything over to the other side to get 16t squared plus, minus 288t plus 1152 equals 0. So here are your two options. One, you can factor this. It's actually factorable. You can factor out a 16 and then factor it. We'll do that. Or you can graph it. Okay? If you graph it, you're going to have to change your window quite a bit because 1152, that's pretty high. All right, so let's go ahead and let's factor this. You could either divide everything by 16 and get rid of it, or you can factor it out to the front, but it is divisible by 16. You get t squared minus 18t plus 72 equals 0. And then let's factor some more. So 16, and you have, what times what's 72? Adds up to negative 18, negative 6, and negative 12. So your answers are t equals 6 and 12. And you might be alarmed, oh no, there's two answers, but that's okay. Because guess what? This is what it looks like. Here you are at t equals, this is t is seconds, and this is s is height in feet. And here you are, and your projectile goes up and comes back down to the ground, hopefully. Okay? And at s equals 1152, which who knows, maybe it's right through here. We can say that's s, sorry. I don't want to write y, I don't want to add another variable. So that's s equals 1152. And that happens at t equals 6 and t equals 12. So one time it happens on the way up, it hits 1152. The other one happens on the way down. So your answer would be 6 and 12 seconds. You would need both answers there. Okay. All right, part B is going to ask you, here's part B, last question of the day. When will the projectile's height above ground be at least 1152? So when will the height be at least 1152 feet above the ground? Okay, that's where inequality comes in, right? Okay, when will the height be at least 1152 above the ground? Well, at least 52 is going to be greater than or equal to, right? Someone says that they're at least 13. Guess what? They could be 13, right? Okay, so what we would say is, and we already have the answers here, which is nice. We didn't have a new number that they gave us. So it's going to be at least 1152 from 6 to 12 seconds, including them. And you can just write that in interval notation, and that would be your answer. Okay, that was 38 minutes.